Okay, now we're going to look at counting, how it's related to probability. We're going to do the product and sum principle. So first of all, the product principle is illustrated with this diagram. You're at town P and you've got 2 ways of going to town Q and 3 ways of going to town R. How many different ways are there from getting from the first one P to the last one R? Well, we could go through 1 and then 3 ways from Q to R. So that is three possible solutions, 3 possible pathways. Or we could take the other path, P to Q, once again followed by 3. So it's 3 plus 3, so we get 6. But the way we do it mathematically is we say there's 2 ways from going from P to Q, 3 ways from Q to R, and because they're consecutive, one after the other, we multiply. That's the product principle. So total there are 6 different ways of getting from P to R. Okay, so over the page we have we could have extend this like this one here would be 3 times 4 times 2. There's that many 24 ways of going from P to S. And now you can do some questions, see how well you can apply that product principle. You can apply it to pathways like in question 1, or you can apply it to entrees, main courses and dessert, or a lock system in 3. So pause the video and come back for the solutions. And here are the solutions to 8A1, question 1, 2 and 3. Now for the sum principle, this is where you can go one way or another way. So if we go from P to Q, you can see using the same theory as before, it will be 2, there's 2 ways from A to B, 3 ways from B to C, so there's 6. The P to the A and the C to the Q are just 1, so that doesn't affect it. So it's 1 times 2 times 3 times 1, which is 6. So that's the first, from A to C, there's 6 pathways. Or we could go down and go 1 and then 4 times 2 times 1. In other words, 8 ways going down below from D to F or P to Q going down the bottom path. We have 8 pathways. Now what we do is because they're not consecutive, we can either go that way or that way. Then we add all those possibilities together. So 8 plus 6, there are 14 different pathways you can go. Notice I was using the word or, and here's a summary here. So and, when you use the word and, in probability it means multiply. When you use or, it means add. So you can see here we're going from P to A and A to B and B to C and C to Q. That's why we multiply all of these, because it's consecutive in one after the other. Or we could go along the bottom, so we then plus, or is plus, we can go along and do 1 and 4 and 2 and 1. So using that now, the sum principle and the product principle we've already learnt, let's see if we can do some of these questions below in 8A2. So you try 8A2, question 1, A, B, C, D, and question 2. And here are the answers, 8A2, question 1, and question 2. Now we're going to look at permutations. This is the number of ways of organising something in a definite order. So for example, if we had the letters X, Y and Z and we take them one at a time, then the 3 possible ways of getting that would be you could get the X, or you could get the Y, you could get the Z. So there's 3 permutations picking one letter out of the 3. If you had to pick out 2 at a time, then you could have X and Y, X and Z, Y and X, YZ, ZX, ZY. And there are 6 different ways of picking out 2 from that set of 3. If you did 3 at a time, it'd take a while to try and work it out, but you can see that also you would get 6 different ways of organising them in 3 letters at a time. Now there's obviously got to be a quicker way than trial and error like that, and the quicker way is explained here. If you were to do say 3 at a time, then for the first letter there are 3 possibilities. It could be X, Y or Z. Now once that's been used there, that means there's 2 letters left. There's Y and Z, so there are 2 possible ways for the second position. And then once that letter's been used, there's 1 letter left, and so now we've got 3, 2, 1. Now it's a bit like the AND principle, the product principle we learnt before. There's 3 ways of the first, followed by 2 ways of the second, followed by 1 way for the third, so we multiply them. 3 times 2 times 1 equals 6. So that agrees with this here, because this is taking 3 at a time, and there's 6 different ways of getting it. Okay, so using that principle, we'll do some questions. We'll just have a look at another worked example before you have a go. If you had A, B, C, D, E, taking 2 at a time, well, there's 5 ways of getting the first one, because there's 5 letters. If you use up 1, then there's 4 ways for the second, so it's 5 times 4. Taking 4 at a time, once again it's going to be 5, 4, 3, 2, and you multiply all those, you get 120. There's another worked example down here, example 5. If you had 1, 2, 3, and there's 6 and 9, they are the numbers. There are 5 numbers there. How many ways can you pick a 3-digit number? Now a 3-digit number, well, there's 5 ways of picking the first, followed by 4, followed by 3. But sometimes you have certain constraints, like in B it says the number has to be greater than 500, in which case the first one you can be 6 or 9, so it'll be 600 and something or 900 and something, because you can't have 100, 200 or 300. So there are 2 possible numbers to pick for the first choice. Because you've used 1 number up, that means there's 4 numbers remaining, and then when you use that up there's 3 numbers remaining, so if you multiply them you get 24. Likewise, C, when you got the first and last digits even, the first one we've got a 2 or a 6, there's 2 ways. Since you've used that 1 even, you've got 1 more to choose from to put the even at the end, and then you've used 2 up, there's 3 remaining. So that's the way of finding the different possible ways of organising these numbers. Okay, so you can now have a go at 8b. There's questions 1 and 2, and question 3 sitting below there, and there are lots more questions here from 4, 5, 6 all the way down to 10. You choose how many you want to do until you can get the idea, so pause it and come back for the solutions. And here are the solutions to 8b. So you've got 1 all the way down to 10. Now there's a quicker way of writing the multiplication of these numbers, because it's always usually decreasing by 1. For example, 5 times 4 times 3 times 2 times 1. What we write instead of that is 5 factorial, 5 with an exclamation mark. That means 5 times by the consecutive numbers going down by 1 each time. And this could be written like this: n factorial is equal to n times by n take 1, that's 1 less, times by n take 2, which is 1 less than the previous, dot dot dot, all the way down to 1. And it's read as n factorial. And so there's an example there of 5 factorial. If we wanted to do, say, 11 times 10 times 9 times 8, and we're not going all the way down to 1, we can express that in factorial form by calling it 11 factorial divided by 7 factorial. Because the 7 factorial is 7 times 6 times 5 all the way down to 1, and that's on the top and the bottom, so they are going to cancel out, and so you're left with 11 times 10 times 9. Right, so that's how you would write 11 times 10 times 9 times 8, 11 factorial on 7 factorial. Alright, do note there are some special cases. Another way of writing n factorial, you could say it's n times n take 1 factorial. That's same as saying that 5 factorial, for example, would be the same as 5 times by 4 factorial. That's pretty straightforward. Also note that 0 factorial is equal to 1, because notice that under this rule we would say 1 factorial is 1 times 0 factorial, and we know that 1 factorial is 1, so we can't have that being 0, it's got to be 1 times 1, so that's why 0 factorial has to be defined as 1. Alright, so now you can have a go at some of these questions. There's a worked example there that we've already kind of seen above, so if you could try 8C and come back after you try them and get the solutions. And here are the solutions to 8C, question 1 to 4. Okay, now we're going to look at combinations. This is looking at all the different ways that you can organise it without regard to the order. The permutations that we learnt last time, order was considered. For example, if we look at A, B, C, D, E, and we want to select 3 of those, in the permutation, if ordered mattered, these are considered 2 different ways. A, B, C, A, C, B. That way the order matters. But if we're talking about combinations, they are considered to be the same selection, because a combination is just thinking about just the letters, not the order of the letters. Whereas if you look at the A, B, C, A, B, D is a different combination to this. Right, there are 2 different combinations. These two are not 2 different combinations, they are different permutations. These 2 are different combinations. Okay, so that's the difference between these 2 words here. So looking at selecting 3 people from 5 possible people to be in a team, there are 10 different combinations. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we need a mathematical way of getting this quickly. So over the page, this is how we do that problem. We write it as C35, selecting a team of 3 from 5 people. And you can do that on the calculator. We know the answer is 10. The way we read it over here, we read it 5 choose 3, or choosing 3 from 5. So the the formula for C35 is written here. It's actually 5 factorial divided by 3 factorial times 2 factorial. Now that actually is, in general form, the 5, the n, you can see here, the number up the top, the 5, that's what gets written as the numerator, n factorial or 5 factorial, using the number example. The 3 on the bottom is like the r, and you've got to have r factorial, so we have r3 factorial, and the remaining one is the top take the bottom, 5 take 3. So we have 5 take 3 is 2 factorial. That's the formula for working out the number of combinations for r symbols taken from n. Now this can be done on the graphics calculator. To do this on the calculator, you've got to put the n in first. In this case it's the 5. Then you've got to find the C, the NCR, which is in math, and you go over to prob, standing for probability, and you can see the NCR sitting at number 3. So it's 5, and then it comes up, and now we can enter in R3, and so that's 5C3, and we just press enter, and the answer is 10. So there are 10 ways of selecting 3 people from 5. Okay, so now we want to do some questions. So 8D, this is, it tells you that you have to use your calculator to check your answers, so use the formula. When you got it in the brackets, that really means C32. So if you try 8D, pause the video and then check the answers. And here are the answers to 8D, question 1 through to 6. And over the page to question 7, before we do that, there's a worked example. If we want teams of 3, select from a squad of 8 with no restrictions, it's just our C38. But if we need something like a captain, then the first position is fixed, so that's 1, which is C11, and then there's going to be 7 people left, so it's the C27. Because the captain has to be followed by all the other people, then it's a multiplication symbol. So you could try 7 to 10. And here are the answers, 7, 8, 9 and 10. Now we move on past question 10. Let's see this worked example first of all. We have a horse team. We need a team of 4, and we've got 7 male and 6 female. We need first of all to select a team of 4. If there's no restrictions, then we don't care whether they're male or female. 7 plus 6, we have 13 riders, 4 to be selected, so it's C13 4. So that's 715 teams, 715 different ways we can organise that. Part B, if we must have 2 riders of each sex, so we need to have 2 males and 2 females, then the ways of choosing the males would be you've got to get 2 from the 7, and we've got to get 2 from the 6 for the females. Now we need both of those 2 males followed by 2 females, so it's an and, 2 males and 2 females, so we use the multiplication from the product principle, and so it's 315 different teams. The last one is at least 1 rider of each sex is required. Now we could have 3 male and 1 female to give the 4, or we could have 2 male and 2 female, or we could have 1 male and 3 female. Now that's what's put here. This is the 3 males, 3 from the 7 and the 1 female, or we could have the 2 males and the 2 females, so 2 from the 7 males, 2 from the 6 females, or we could have 1 from the 7 males and 3 from the 6 females. Because I'm saying or, we could have that, or that, or that, then we use the plus from the sum principle. And so adding all them up, we get 665 different teams that can be selected. There is a note here that we could have achieved the same answer 665 by looking at the total number of ways we could choose people. That's 4 from the 13, which you've already worked in part A is 715, and we subtract off the cases that this question doesn't involve. Now this does not involve this case, the 4 males and the 0 females, 0 males and 4 females. Now the probability of selecting 4 males is 4 from 7 times by the 0 from the 6, and the 0 males and 4 females. If we take off those 2 possibilities from the total, then we'll end up with the remaining, which is this case 3 males, 1 male, 2 males, 2 females, 1 male, 3 females, because all of those is 100%. Okay, so the next set of questions is 11, 12, 13, 14, 15, 16. 13 is asking you to go back to the opening problem on page 204, and that one is, if I go back to the opening problem, which is this one here. This is students on a week-long camp, and these are the questions here. So if you pause that and try and do some of those. And here are the answers for 11 through to 16.